We're going to recap on surds again today. So I'll go through a little introduction and then I'll give you a lot more notes on simplifying surds. So make sure you are copying out the examples as I go over them, and then I'll post this video on Teams so that if you do want to replay it or pause it at certain parts to re-listen, then you can do after this video. So a surd is just an irrational root where the word irrational means that the number cannot be written as a fraction. Rational numbers can be written as fractions, like the whole number 6 can be written as 6/1, and your decimal numbers like 1.5, 1.5 can be written as 3/2. So a surd in particular is an irrational root, such as √2 or √6 or √10, because they cannot be simplified. Things like √4, the square root of 4 is 2, so that can be simplified. The square root of 36 is 6. So a surd is just an irrational root that cannot be simplified. And irrational numbers are just numbers that cannot be written as fractions, like the pi symbol, 3.14. So we're going to go over a few examples together. So if you could copy the first example here, 4√7 subtract 2√7. When you're completing questions like this, just think of your surds, so your √7 here, like an x, if that helps. So 4x minus 2x is just 2x, and then 4√7 minus 2√7 would be 2√7. So basically the rule is root a plus root a is 2 lots of root a. So as long as your roots, your number underneath the root, is the same, you are able to collect like terms and add them together or subtract them. So example 2, 5√2 plus 8√2. So look at the coefficients first, 5 plus 8, and then attach that to the surd √2. So your final answer is just 13√2. For the third example, 3√5 plus 2√5 subtract 7√5. You have 3 terms here, so take your time. 3 plus 2 is 5, subtract 7 is -2. √5 was your third part, so the final answer is just -2√5. And the last example here is slightly different. It's not in the notes, I've just added it in because we have a different term at the end here. We can only collect like terms for the first 2 terms. So 3√5 plus 2√5 would be 5√5. But we cannot do anything with the 7√2, so that just gets left here. So the final answer is 5√5 subtract 7√2. Now I'll put another booklet onto Teams because the Zeta Maths textbook is quite short for this topic. These questions will be quite straightforward. Just make sure you're copying them into your jotter and then writing the answer underneath. So you'd be copying out √5 plus √5, 2√5 would be your answer. Now, I will let you do that afterwards. Let's go over simplifying just once more. So I'll let you watch a video on this yesterday, but I'll go over some more examples just to make sure you are fully understanding the working. So, first one, √12. We are going to think of the factors of 12 before we begin to simplify this. So the first pair would be 1 and 12, and then keep dividing. So divide by 2, you've got 2 and 6, you've got 3 and 4, and then 4 and 3, so we stop there. Now you're looking for the largest square number out of all the factors. Now 1, 12, 2, 6 and 3 are not square numbers, but 4 is. So you would want to use √4 times √3, for your factor pairs that are going to help you simplify the surd. Now, root 4 can simplify because the square root of 4 is 2. And then we just attach root 3 because that cannot simplify. So our final answer would be 2 root 3. And I'll go over a few more. So, root 45. And the more examples that you do, you'll end up just finding the final answer straight away. But for now, list your factors at the side. So 1 in 45 won't be helpful because you'll just still end up with the question. So you would want to keep trying. So we've got 3 multiplied by 15. You have 5 multiplied by 9. And that one looks nice because 9 is a square number. So we go for root 9 times root 5. Now I could write this as root 5 times root 9. I'm writing it as root 9 times root 5 because I will be square rooting the 9 to get 3 and then attaching it to the root 5. Okay, so square root of 9 is 3. Root 9 times root 5 gives you 3 root 5. Right, root 72. So be careful with this one because a lot of people don't use the highest square number first. Now, when you're listing all of your factors, just keep dividing by 2, then 3, then 4 to list them all so that you can choose the highest square number. So 1 in 72, 2 in 36, and you're like, oh, that looks nice because 36 is a square number. If you were to keep listing some other options, we could divide it by 3. So 30, 60, 24. So 3 times 24 would not be helpful because 24 is not a square number. And then you could also try dividing it by 4. So 18, yeah. And then try dividing it by 5, 6, yep, 12. And then keep going. You have 8 and 9. And then that's it. Then it would be 9 and 8. So we have a few square number options here. We've got 36, we've got 4, and we have 9 as well. But you would want to go for the largest square number. So you'd want to go for 36 times 2, root 36 times root 2, because that would give you the answer straight away. If you had accidentally chosen 9 and 8, because I feel like people would go for root 9 times root 8 because they're more confident with their 8 and 9 times tables to get the 72 there. That wouldn't be a major problem. You would just have more working to do. So if you went for root 9 times root 8, you would get 3 root 8. The only thing is people might think that's the final answer, but it's not because you can simplify root 8. You would have to keep going and work out root 8, which would be root 4 times root 2, and then keep simplifying that. So eventually you would get the same answer, 6 root 2, but with a lot more working. So you want to go for the largest square number. And we'll go over one more example, root 147. So try your best to go for the largest square number when you're listing the factors. So 1 in 147, not very helpful. Can't divide it by 2. Let's see if we can divide it by 3. So 3, 6, 9, 120. So 49 is going to work. 3 times 49. 49 is a square number, which is great. You can get to the answer straight away now. Square root of 49 is 7. So your final answer would be 7 root 3. Now I'm going to let you try the Zeta Maths textbook questions again. So they were on page 7. Yeah, this is the right exercise 2.2. So make sure you're using our Teams page to access the link, or you could use this QR code on the screen just now. And make sure you're checking your answers at the back of the textbook. But if you're unsure at all and you have your headphones with you, you could always go back and attempt some of these examples again. Just make sure you are fully understanding them. And I can go over some more questions with you when I return to work. Thank you.